Okay, so now we're going to continue talking about confidence intervals. So we talked about those in chapter 8, and now we're going to go ahead and talk about them with two samples. So we're going to compare the two samples by looking at the difference in the proportions in the two samples. So one of the main things that we have to make sure of is that we have, they come from two random samples, or our two groups are arranged in an organized or randomized experiment. So we have to have this randomization so that way there's a purpose. We can use inference to be able to go back to the entire population if it's a random sample, or if it's a randomized experiment, then we can establish some cause and effect. Now we're going to be using this statistic p hat 1 minus p hat 2 to estimate the original proportion 1 minus the original proportion 2. And those being the original proportions of the population, which we won't really know, but this gives us a good idea of what that should look like. So we're going to do our confidence interval formula where we take the statistic, so that's that p hat 1 minus p hat 2 plus or minus our critical value. And so with proportions, this is going to be our z star. We do that by doing the inverse norm to find a z-score kind of for that value. And then we're going to do the standard deviation of the statistic, which is really known as our standard error. And so then we get this whole idea that everything over here is that margin of error. And so we've talked about margin of error. Now we really have a new formula for that standard error, and we talked about that yesterday, where we're combining the standard deviation formula for one sample with the standard deviation of the other one, which means we have to combine the variances. So the standard deviation of one squared plus the standard deviation of the other squared, and then we square root it to find the new standard deviation. And so that's the formula that we're going to be working with. So now we're going to go on over to the whole thing we have to do for a two sample z interval. So the first thing we do is we state that we're going to estimate the difference in proportion between two different things with a certain confidence level that we decide or is decided for us in the original problem. And then our plan is we're stating that we're going to use a two sample z interval for proportions, and we're going to check our conditions. So our conditions, very similar to what we had before. And that is our random condition. So again, both samples have to be random, or two groups of size N1 and N2 that are in a randomized experiment. Then we have our normal condition, which we have to check for both samples. So we have 4 different things that we're checking to see if those are greater than or equal to 10. And then we have our independence condition, which really we have to say that both samples are independent and the observations are independent. So we want to make sure that one group's observations does not affect another group's observations. And then those observations within the groups are also independent of each other. So again, still using that 10% rule if we need it. Then from there, we're going to go ahead and we're going to perform our calculations. So if we need to, we're going to calculate P1 hat and P2 hat and then calculate what the differences are. Then we're going to go to our critical value, our Z star, and we can do that by doing our inverse norm, or we can do that by actually calculating or going to our table. So we have table A that we can look up a Z-score for, or we can use table B. And table B is truly our t-table. It looks at our t-distributions, but if we look at that infinity number at the bottom, remember it tells us those z-scores. So it's a nice little shortcut for finding those z-scores. And then once we've done that, we go ahead and compute that interval where we've got the difference between the samples, we've got our critical value, and then we have our standard error. And then we go through and we calculate that. And remember, we have the plus or minus, and that's going to give us a lower bound and an upper bound for our interval. And then once we have that, we go ahead and interpret our result. We are blank % confident that the interval from blank to blank captures the true difference in the proportion of so on and so forth. And always going back to what is this really telling us about the situation. So now we'll walk through one problem together. Are teens or adults more likely to go online daily? The Pew and Internet American Life Project asked a random sample of 800 teens. Let me grab my highlighter real quick. So we have, let's see, 800 teens. And let's see, of those teens, 63% say they go online every day. And then we have 2,253 adults, and of those, 68% say they go online every day. And we're going to construct a 90% confidence interval for P1 minus P2. And we can really decide that in our thing. And so that's something that we have to state. Estimate the difference in proportions of teens, which is going to be our P1, and adults, which is going to be our P2, that go online every day with 90% confidence. So now we're going to use a 2-sample Z interval for proportions. We're going to check our conditions. So it looks like we have an SRS of 800 teens. And we also have an SRS of 2,253 teens. Oops, adults. I apologize. That is adults. Okay, that doesn't look good. Oh, wait. Okay, so then we're going to go ahead and check our normal conditions. So I'm going to check for teens first. So 0.63 times 800. I'm going to check what that is. Let me grab my calculator here. 0.63 times 800 is 504, which is definitely greater than or equal to 10. And then I'm going to check the remaining, so 0.37 times 800, which is 296, which is also greater than or equal to 10. So our teen sample looks good. Now we have to look at our adult sample. So 0.68 times 2,253. I don't know what is up with my fives today. 50. There we go. That looks more like a 5. And this gives us 1,532.04, which is also greater than or equal to 10. And now I just kind of want to address the idea that we're getting a decimal here, and that's okay. That's probably because the original percentage was rounded. We don't need to change anything. So we just go ahead and leave it in the decimal to show that we calculated it correctly. We didn't mess with our numbers at all. And so then we check the remaining percentage. The 32% gives us 720.96, which again is greater than or equal to 10. So now we've met our normal condition. Now we're ready to move on to independent. And so now we have to look at, let's see, easily more than 8,000 teens. Thank you. And more than, let's see, 22,530 adults. And so that kind of talks about within there, we don't have to worry about the independence there, but we do have to worry about will teens percentages affect adult percentages? And it's reasonable to assume that teens and adults are independent. Okay, so now that we have that, we're going to go ahead and start calculating our information. So first we're going to start with Z star. So we could go to our table B and use our infinity level. or we can go ahead and inverse norm. And since we have a 90% confidence level, we take the remaining 10%, and then remember these are our tails, so I divide it up into two tails. So there's really an area of 5% on each tail, and a mean of 0 and a standard deviation of 1. And this will give us our critical value, which is 1.645. So now that we have that critical value, we're ready to set up our confidence interval, where we are going to take our proportion of group 1, teens, minus my proportion of group 2, adults, and then I'm going to create that margin of error. So now we've got the 1.645. And then we've got our standard deviation. So the square root of my first sample, 0.63 times 0.37, all over 800, because that's our sample size. Plus, now we're going to go to our adults, 0.68 times 0.32, all over our sample size, 2253. Yep. And this will give us our confidence interval. So now our difference is really negative 0.05. There we go, plus or minus 1.645 times our new standard deviation, which is 0.0197. So now we're going to have a negative 0.05 plus or minus, let's see, a 0.0324, which gives us an interval that goes, so I'm going to do the 0.05, the negative 0.05 minus this value, so this is going to give me my lowest value, which is negative 0.0824. And then I'm going to go to my higher value, so I'm now taking the negative 0.05, I'm adding the 0.0324, which is going to give me a negative 0.0176. And so now we have our values, so we are 90% confident that the interval from negative 0.08 to negative 0.02 captures the true difference in the proportion of teens and the proportion of adults that go online every day. And so then usually we'd have a follow-up question that would say, well, is it possible that these proportions are actually the same, that adults and teens go online the same amount? And since 0 is not in that interval, that would not be true. And in fact, we kind of have convincing evidence, because remember how those confidence intervals go hand in hand? We have convincing evidence here that actually adults go online more often than teens, based on this set of samples. And so again, these samples were done probably about 6 or 7 years ago, and it would be really interesting to see what the data says now, if that's truly different or not. Okay, well that's it for today. Next time we're going to talk about significance tests, and again, all very similar to what we've done in the past, but again, a good idea to practice.